Okay, go ahead.
Okay, I have a question from module 2, from one of the exercises of sampling design. It's on page 17 or 18. I just recently saw that you have the annotated version, so maybe I could have seen it, but I just was wondering because in the random number selection, the line, I just noticed that I had other numbers that I could have chosen, but particularly in the exercise, they weren't like chosen in that order. So I wanted to.
The order doesn't matter. I mean, okay, well, let me see. Let me get the page up and then let's be clear.
Okay,
I
I
am
think I gave you the wrong number. Let me check. I'm checking my notes. Actually, I'm sorry. Exercise. It's from the practice examples, number 2.
I'm gonna share my screen. So it's from the practice part. It's from
Yes, I actually got it off from the module per se from that document,
okay, let's
but
go to the ONET annotated. Okay, so page, what did you say?
it's like the last one, the 29th, one of the last ones.
Okay.
That one, exercise number 2.
Okay.
No, not that one. A little bit higher, I think. Okay, that one. So I was just
This
wondering,
one. Okay.
yeah, the numbers that have been chosen, they then don't matter the order. It doesn't matter.
Okay, well, let me be clear what we're saying. Okay, so they just put them, no, they didn't, did they? Okay, so the numbers down here don't match what I wrote here. Is that what you're saying? Starting at the beginning list, the first 12 numbers between 0, 1 and 1, 2 are.
It's just that, it says 05, and I see a 07 before. So I was just wondering if there's any particular rule of how you should be choosing the numbers, or it doesn't really matter.
Hold on a second, because I don't know what's going on here. What happened here? It might be a typo here. What is all this? Starting at the beginning of the list provided in the first 12 numbers between 0, 1 and 0, 12 are, okay, so I was just marking. Okay, I was just marking them. Okay, so 15, so you could see them 68, 91, 42, 27. Okay, so this is the first one, 06.
Yeah.
And then 56, 51, 43, 74. So I go all the way to 9. So yeah, I'm putting them in order. I mean, I'm putting them in order of occurrence. So 6 is underlined, 9 is underlined, then 3 comes. Okay, so what's your question?
After 3, I see a 07, but
After 3, because we already picked 07? No,
no.
we didn't. Oh, but it's not 07 because you have to take 2 at a time. So those are gone.
Oh, that was the why that yeah, that was the
Yes.
question. If there was like a rule when choosing them, because I had like I was
Yeah.
wondering why it didn't match.
So the rule is you use labels the size of
Oh, okay.
like the equal size labels. So there are 12 items labeled. So it means that you have to use digits of 2. So that's why they're numbered from 0, 1 to 1, 2. So I take 2 at a time. That's why these are highlighted. So until you can see it. The bold and then the other one. So those are all numbers 15, 68, 91, but none
So
of those fit. So
you
yeah,
could have chosen, for example, in the first one, you could have chosen 15, and then if you had a number up to 90, you could choose
exactly.
81.
Exactly.
Okay, perfect. So
Yeah.
you leave one in between.
You leave, well, we're doing two. What do you mean one in between?
Oh, okay, so you could choose 15 and then for example, 68. If you use
Exactly, exactly. Yeah, I'm not leaving it. I could have taken the non-bolded one, but it happens that most of the time, oh, see, here's 5. It wasn't bolded. So yeah, you take 2 at a time. And it's just a way that I mark them just so you could see it, that they're not the numbers that we need between 0, 1 and 1, 2.
Okay, so if we have 3 numbers, then we will work in 3 at a time.
Exactly,
So
yeah.
that by that you would only use like 1 number in each column, right? If we had that example.
So if you had 3 digits, you would go 3 at a time.
And you couldn't unite the 2 columns, right? You couldn't use like 891.
Where's 891? 891. Well, if you're doing 3 at a time, yes, you would. You would go 1, 5, 6, and then 891. I can't do
Okay.
it. And then 4, 2, 2. Yeah, we'll go 3 at a time all the way consistently through.
Okay, I understand that. Thank you very much.
Okay, yes, no problem.
I'm sorry, I have 2 other questions from a quiz that I did online.
Okay.
I was just wondering which was the answer because I got 2 wrong. And I was looking back and
Okay,
forth.
okay, let's talk about it. So quiz, which one?
The 2.1 and the 2.2.
Okay, so which one?
It was, I think, the third one. Yeah. No, let me check my notes really quickly.
Mhm.
The fourth one.
All right, so this is very common for people to get wrong because they mix or they don't understand or they don't clarify the difference between stratified and multi-stage. And I assume you watch the videos, right, Patricia?
Yeah, let me check something. Yeah, that was the one. I chose multi-stage, but
Right.
I'm guessing it's stratified.
So, right. So you have to remember from the discussion and the examples I provided about multi-stage and stratified. I did explain the difference. I did describe them, right, in the video. Just going to confirm that it's there in the supplemental video that I gave you.
I think so.
Just to make sure that I'm not imagining things.
I could be wrong because I'm getting them confused, but if anybody else.
So in the supplemental video, let me see. Sometimes I say I send you guys somewhere else, but no, I'm pretty sure I describe it there because I can talk about it again. So I put this one here, empieza 1:28.
Oh yeah.
So did you watch this?
No, not that one. No, I entered
That's
actually the last
that's
one.
where I explain it. I didn't explain it in class because we didn't get there.
Okay, perfect.
This one, okay. So I don't use my own rule. So about using Braid browser. I have Braid browser linked as my default browser. So I don't have ads, but I unlinked it for some reason. All right, so where's the discussion? Let's see. Do I put it here? I think it's all after the experiments. And then okay. Here. So how much time do I have? 20 minutes. So I explain it here at the end. So the last 20 minutes.
Okay.
What I say, I explain all of this, okay? So let me just tell you in a short form. The difference is the motivation. The motivation for stratified is representation. If you believe, like in the videos, you watch the videos, right? I'm putting you on the spot here, but in the videos, it shows you, I'm talking about the decision through data videos, and it shows a map and it starts talking about a census or survey and trying to represent the different types of communities, urban, suburban, and rural. And they make a point in the video that it's possible, because so many people live in the city, that if you take a random sample, you won't get anybody in the rural area, because there's not that many people in the rural area compared to the city. So to make sure you get representation, you separate them into strata. They call them strata, and then sample randomly inside each strata. So you're going to sample some people from the city, some people from the country, some people from the suburban area. So that is because that's stratified sampling, and that is the motivation is representation. Otherwise, you don't get anybody from, likely no one from the country. Now, having said that, you would analyze those groups separately and report them separately. But that's the whole point, that you want them to be represented, and you can figure out how you're going to combine them so they represent the country or the island of Puerto Rico, for instance. But that's another issue. The point is that if you don't do that, you're going to miss people, right? That have a different lifestyle or different, just different. They're just different experience for income and employment. That was the issue. Then, okay, so that one's clear, right? So that's representation. When it comes to multi-stage, the motivation for multi-stage is different. Did anybody understand what the motivation for multi-stage was? Let's see the others. I put you on the spot. Uh-oh. Someone wants to talk with a bad microphone, or is it me? Nobody? Okay, so the motivation, so make sure you watch this. If you don't watch anything, just watch the last 20 minutes. So it's going to be really hard if your goal is to represent households in the rural, suburban, and urban areas. That's a lot of households, right? So if you want to, we learned repeatedly in the videos that we have to the first step to sampling is labeling. So you have to label all your units that you're going to sample from. Well, how are you going to label all the units if you don't have a complete list of all the units? So it's possible that you will have to spend a lot of money, a lot of resources trying to get a very up-to-date list of all of the people who have, in households, or all the households, because people move, especially in the city. Who's really the owner? How do you get a contact information? In the rural area, sorry, it's going to be more difficult, right? So to avoid all of that, there's another approach. So the motivation for multi-stage sampling is it's cost saving in terms of trying to identify your target population, getting contact information, and labeling all of them. So to avoid that additional cost, you use a list that's easily accessible. And you go backwards. You start at rather than start with labeling the households, you start with labeling a broader metric, a broader thing that we track. And that could be, I used regions. So we're going to label regions. Now, let's say in Puerto Rico, you could say municipalities, right? So there's 78 municipalities. Well, let's say I just use an example of 30. So you have 30 regions in a country, and you label those ones. So because they're 30, your last number is 30. So you use 2 digits, 01, 02, 03, all the way to 30, and you take a sample from there. Then from inside of there, you go to the next level. So you approach the households from a higher level. So in the next level, you go for each of those 10, because you have 10 regions. You sampled in my example, 10 out of 30. And in those regions, you go ahead and you look for a different kind of measure or list. And it's very easy. Let's say that you have a list of communities, because you can get that from the tax office or from the municipality itself. They'll give you a list of the communities, right? So then from that list, you can start labeling. Let's assume there are 30 communities in each one. And you start labeling, okay, so 01, 02, all the way. So you could have, let's say some communities have 30, some have 25, or some have 10, some have 100. Still, you take a percentage of each of those. So if they have, 100, you use 20%, that's 20. If there's 10, you sample 2. So it's something like this. Now, these numbers here, I'm coming up with these numbers arbitrarily, like I'm just telling you these numbers. Those numbers would be determined by a statistician, like how many is good enough, right? So anyway, so then what you do is you label the number of
excuse me, Professor, I was gonna ask you that, because in step 3, for example, the 2% would be made up by what you just mentioned, like a mathematician or something like that.
Yes, yeah. You won't, I mean, you could, if it's really important, like a census, US census, you're gonna get statisticians in there and they can debate what the right number is and use some estimates to get the right number. But in general, you can use, like if you're just doing this for, like, say, a marketing survey, you can just come up with some sort of, agreed upon number as a percentage of each region and work with that. So it doesn't have to be so serious, but, just to get some, idea of your target population and opinions. So you could just do that. But yeah, if it's a very serious thing that a lot of people are going to see and you have the resources, you hire statisticians and they find that number for you. So then out of here, you're going to use 20%. 20% of 30 means 6 that you're going to pick from each of the 10 regions. Okay, so like a lot of numbers here, but so basically you're going to label 01, 02, 03 up to 30, and then sample inside of there, picking 6 each. So now you have 6 communities in 10 regions, so 60 communities total. Are you guys with me so far?
Yes.
Then you go to the next level. The next level is that you say, okay, so let's go deeper. So next there's the blocks, like the, the blocks that are like 1 acre or 2 acres, or I don't know how many there are. There's probably a standard. I don't know if there's any planificación people here, they will know. So you go to blocks and you start labeling how many blocks. So let's say it happens to be 200 blocks in each community. So we label 001, 002, all the way to 200. And we were told to sample 2%. So 2% of 200 is 4 from each, 4 blocks from each of the 60 communities. So then you do that, 4. So all of this is done without even having an address. You don't even have an address yet. Got it? So once you get to this level and you've determined the blocks that are going to be part of your study, that's where you try and get a list of households in those 240 blocks. And that's easier than going after 18,000 households in the whole, in a country, if that's what you wanted to study. 18 million, what did I say? 18 million. So this could be, in Canada, let's say there's 18 million households. And that's just, overwhelming. You're not going to be able to get an up-to-date current list with contact information for those people. Just people move, things change. And is it worth it? No, you can use multi-stage and still, saving money and getting very accurate analysis of people that we've determined are representative of the whole. So when we get down to the blocks, we find, let's say, let's assume there's 100 households on each block. And so we label them 001, 002, all the way to 100. And we were told to sample 5% from each. And then with 5% from each, I'm running out of, let's go a little down. So then with 5% from each, you're going to have 5 from each of the 240 blocks. So all you have to study and interview are 1,200 households. But at this level, how many households do you have to find the address and the contact information for? Let's see, that's a good question. So there's 100 households in each block. 240 blocks. So that's going to be 24,000. You have to get 24,000 addresses and contact information rather than 18 million. So that's quite a cost savings. So you didn't do any searching or, attempt. You made no attempt to get the household information until stage 4. All right. So the issue here is we use multi-stage as an efficient tool. And when numbering or labeling all units is prohibitive, or it's really, it's very expensive, time consuming. Got it?
Yes, thank you very much.
So going back to the question, in the question, it says Census Bureau survey. Oh, let me talk a little bit about combining them. So the Census Bureau combines these efforts. So they'll divide into strata, suburban, urban, rural, and then within each of those, they do multi-stage. So they combine them. And that's what the video explained. And maybe it's confusing because they kind of threw those things together, but they're combined in the U.S. Census Bureau survey for both reasons: one, for representation, and two, for the labeling issue and cost issues. And so then inside of there, to get that each state has proportional representation, that would be the stratified sampling part. But if I ever mention, cost of identifying study units is prohibitively expensive, then you say you should do multi-stage design.
Okay, thank you.
Okay, so that, just to say again, the reason why any of you might have gotten confused, and most students get confused by this, is probably because in the video, if you remember it, they threw them together, so it's hard to tease them apart. Okay. So that's the main thing about that. And yeah, finish watching that video. It's just I said to start at 1:28, so you have like another hour to watch because it goes till whatever.
Do we have time for another question? I just
Yeah.
wanted to know at least the answer of number 4 in my quiz 2.2. Is about a group of 8 people that are doing a weight loss survey.
Oh, sorry, 2.2.
Yeah.
They all decide that they want to lose weight by increasing their physical activity. 4 of them decide that they will always walk up to the 5th floor rather than taking the elevator. I don't remember making this question. It was a long time ago, but it's good. The other 4 decide to always take the elevator when they're going to the 5th floor, but to take 30-minute walk around campus every day after lunch. The 8 people weigh themselves each Monday morning and report their weight to the supervisor. This is an example of...
So I was in between a block design or honestly observation. I chose the wrong one. I chose randomized comparative because I don't know, I thought some
So the problem here is you don't have any control group, because these are people, number one. You have to have a control group to be a comparative experiment. And you don't have that. You got it? There's no control group. I don't identify people, not doing anything here. They're very engaged. They know what they have to do. They're carrying out, and we're comparing 2 groups. The answer should be observational study, right?
Okay. Yeah, I was in between that one too.
So there was no control group. There's no random assignment. They just decided what they wanted to do. So the problem is, in terms of statistics and attribution, is they chose themselves which one they wanted to do. Now, obviously, it's not great to force people to do things. So anyway, all this has to be voluntary, but it would be a more of an experiment if you would say, okay, you want to be part of the study, you do like you do a sort of intake analysis. You have some people doing nothing. You tell them, the construction is the issue. Can you really construct a good experiment for this? But you would have to have a control group where remembering, sorry, I'm interrupting myself, remembering the 3 pillars of good experiment, right? Representation or control, randomization and replication. This suffers from control and randomization because you didn't randomize anything. You just said, whoever wants to go walking up the stairs, you can go walking up the stairs in the other group. So it's not that this doesn't offer any information. It does, but you're going to get observational study results. There's no random assignment and you don't have a control group, but you could have constructed something where you say, okay, who wants to participate in a weight loss study? And that people commit, and it's an honor system because you're not, well, I guess you could videotape everybody and what they're doing with cameras to confirm that they're actually doing it. But the third group and all these groups of people, obviously the different groups can't talk between groups, but they should all be doing different things and there should be a group doing nothing so you can have the control. So this is obviously exercise and weight loss studies like this are hard to design, but the observational information still is valuable. It tells you something. And then you can try to develop an experiment that's much more rigorous to be able to attribute the additional, walking around at lunch as something more. There's a lot of interesting research that, looking at exercise. And even right now, it's very popular to study intermittent fasting. A lot of new interesting studies coming out. And I don't know, I haven't had the time to see if they contradict each other, but my sense is some of them contradict each other. And then talking to people, do you know what intermittent fasting is?
Yes, I also agree. I think it could be good or bad.
Yeah, I'm one of my sisters. I have 3 sisters, and one of my sisters says she can't do it because then she gets more hungry and she eats too much when she starts to eat again. And it's, that's anecdotal, but in terms of the research I've seen lately, it's really a positive thing, but it's a matter of observing people over a long period to see if they can sustain it. One of
I think like the age, because the metabolism sometimes it's even better to continue eating so that your body can keep burning the fuel. So that's why I don't know very well. Like,
yeah.
Great.
Well, the one thing about intermittent fasting in my personal life is that I never ate breakfast for years, and everyone was always after me. Oh, eat breakfast, and I just never did. It's just the way I operate. I'll eat at like 11 or 12. I'm more like a brunchy person. I'll eat breakfast sometimes, but very infrequently will I have something until lunch. And so I did it kind of naturally. So it's kind of nice to have that research to defend myself, and say, hey, look at all this research. This is supposed to be really a good way to maintain your metabolism and your weight. But definitely is lots to look at, and I haven't had the time to do a good look. But the last few studies I've seen, they were very positive. You got to be careful because there's just trends too, and the media sensationalizes things, and they're always on to the next thing. So anyway, any other comments? I see a question or comment in the chat. Question 4 on quiz 2.3. So you guys, you're learning then. These are refining your understanding, I hope, these quizzes and problems.
Yes. Is there any way that when we get the results, we could see like the right answer? I don't know.
You don't see it on the quizzes?
No, that's why I asked, because if I could have seen at least I could like try to.
Oh no, but you will see. Okay, I see, because you have to keep trying it, right? If I put a deadline, I used to have a deadline, then you can see it, but then that pressures people to do it right away, and then people don't get a chance to do it. So did you just do it repeatedly? Like, you just have to do it again and again, and you'll get the answer. Eventually you'll see, until you get it right. Got it?
Okay, I'm gonna check if I had the option to go ahead and take it again, because I didn't verify that.
Let me see. If I do this and I just pick here. So it's going to tell me if I got it right or wrong, but it won't tell me. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So it tells me I got wrong, 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 wrong. So, so this one was right. So you just work on these 3. You have to remember this one and then just keep working on these. So it just forces you to repeat. So if I want to do it again. So, sí, reintentar el cuestionario. You can try it again. And so I know it's this one, but then I have to try these other ones. So like I say, if I put a date on it, then the people who don't get around to it will never have the opportunity to do it. So I leave it open till the end of the course. So now I got this one right. And oh, I thought it was the first one I picked. Oh, did it randomize? So you got to remember, I think because they randomize, is it? I don't remember what I did. So yeah, so you just got to remember your answer. So it's a study tool. It's just a study tool. And I think I'll tell you right now that the quiz problems are just a little harder than the test questions I'm going to give you. The homework is like easier than the questions I'll give you on the test. And so between the homework and the quizzes and the practice is your test. The quizzes are more challenging. So I was going to do one. Okay, so they randomize. So yeah, you have to write it down or make a note so you remember. So I'm forcing you to read the questions and hopefully learn. Okay, did I do 2.3? So question 3.2, quiz 3.2, question 4. Okay, so it's not question 4. So Edgar, you have to tell me which question it is that you want me to do because they're random.
No, it is still question 4. What
Okay.
they do random
If
is
you repeat,
the
if I
order
repeat.
or the
Okay, so
is the one with the fertilizers.
okay, you are going to run a field experiment to investigate the effect of 4 fertilizer on the yield of wheat. You have 40 plots of land available and you wish to run a block design. Okay, so what is the key point that you need to remember about block design? How can you summarize in a few words?
Yeah, what I did was that I put the 40 plots. Let me see what was the first one that I picked. I put the 40 plots of land into blocks of 10 plots each, and with the 10 plots within the block being as similar as possible, and then randomly assign the fertilizer to each block. That's what I initially picked.
Oh, no. So the problem is this. You got it wrong right there. I think if I understood you correctly. So the blocks will behave as a unique experiment in a way. So each block will get all the treatments. That is the key thing to remember about blocking. So it's like within the, so you use a natural, an observation that, okay, this group of participants or subjects will respond differently than another group. So it's like stratification. You're going to say, okay, I want to know about these different blocks. So I'm going to put men here and women here. In this case, I'm going to put, I'm going to use a block. In this case, let's say 10 blocks. It doesn't explain why we have the blocks, but there's a reason to block. There needs to be a reason to block. So with the example in class I used was men and women and their difference in responding to hormones, women having different like 3 sex hormones to manage and men only having 1, and it just makes results different. So we have to block among gender. Again, this is something that I explained in that extra video that will help people if they didn't understand this from just reading the notes. So you're going to block with purpose, and then it's not random. It's like, oh, I got to separate all the men from the women, or I have to separate all the plots that are such and such from the other ones. So it could be urban, suburban, rural, let's say. So it's like stratification, but the difference is this is an experiment. So inside the block, I apply all the treatments. So which one says that? I randomize all the treatments in each block.
Is it C, randomly assign the 4 fertilizers to the 40 plots?
I think you got to block them first. You got to find just like think back to the movement. So first you identify the blocks, then you randomize within the blocks. Which one says that? So put the
Letter
40,
A.
yeah,
Put the 40,
go on.
put the 40 into the 4 blocks or the 10. 10 blocks, yeah, I believe that you have to have the four treatments to each block.
Being as similar as possible, and then randomly assign the 4 fertilizers to the 4 within each block. So you're preparing like mini experiments between 10 blocks. Now, why is B wrong? B is wrong. Let's see. Put the 40 plots of land into 4 blocks of 10 plots each, with 10 plots within the blocks being a similar spot, and then randomly assign a fertilizer to each block. But there are how many fertilizers? Oh, it doesn't say.
4.
There's only 4. So yes, so that's why we got to have the 4 treatments in each block. That's why A works.
Got it.
So the steps are naturally separate them blocks by whatever reason you're blocking. And then within each block, it's like a mini experiment where all treatments are randomized. Thank you for the question.
All right.
Yes, and each experimental unit. Okay, so Patricia, it's not that each so when we did, I taught about in the video 2, in that additional video, supplemental video, I taught about matched pairs. And when you do matched pairs, that's when each experimental unit. So when I talked about matched pairs, I used the example of Pepsi and Coke, and I said when the Pepsi challenge was underway in the past, each individual would receive each can of cola, and they had to decide which one was good. So in that way, they're receiving both treatments. But matched pairs is a example of a block design where, in that example of the Pepsi and Coke or the Pepsi challenge, the person behaved as their own block. But in general, the block, whatever the block is, as similar as possible. And that's the argument to use the single person. From tasting one can of cola to the other, it's the same person with the same preferences. You try and make it, each tasting as similar as possible. The person doesn't change their opinion. So you could make them drink water between sipping the cola so that one sip doesn't affect the other, their sensibility about the other cola. And the order in which they drink them is randomized. Anyway, watch that video. I hope I explained it well. And then a block design acts like that. But in this case, the confusing part in this one might be because I don't explain the rationale for the block, but there must be a rationale behind this to block. And then you have, in this case, we said we have a bunch of plots. We're able to identify 10 different blocks, and they could be for different reasons. The plots have different facing, a different direction. One gets the southeast, one gets the south, one gets the southwest wind. So you want to study that, and so that's kind of how they're blocked, because with the wind they bring different types of seeds to the plot, and or different pests or whatever it is. So the blocks could be defended maybe that way, that you have 10 different directions on this large plot of land, and they're going to have different environmental conditions. So we're going to separate it into 10 blocks. So I'm giving you a backstory for why they're blocking, but in fact, we believe that they're predefined to respond differently to the fertilizer. So I have the blocks, and then within the blocks, I need 4 plots, and they're all similar enough that they all have the same environmental conditions that within the blocks, I can separate and apply 4 different fertilizers randomly. So each block is independent. That's a strong word in statistics. I have to think if we say it's independent, but you'll see independent is a strong word. But yes, I guess they're going to repeat the experiment within the block. So you're going to have 10 experiments repeating the 4 treatments randomly assigned. Okay, questions, more questions. So you guys you're following, or you're
So basically the last list, the answer would have been A.
it was A, I think.
Right.
I didn't check. I think it's A. We should check.
Maybe A and D were very similar, but I think the A did include
Let's see if I get it right.
getting all the treatments to each of the blocks.
Yes. Yes. Oh my gosh, I was nervous. Yes, it's the first one.
Okay.
So you're hitting on all the points that students wrestle with. Okay, so it's very normal, the questions you have, and I anticipate them. So no surprises. You guys are right on schedule. Okay, yes, and the annotated, oh, then there's the homework. So all this study material here is just to practice with. You know, as the test comes up, I will also have some review, like midterm review questions. So you don't have to save any of these, but you might want to keep notes for yourself about what you learned here so that you don't have to go back again. There's so much material. Or maybe, yeah, you make a note so that you can go back and review it, and just the parts that challenged you. So how did you do with the material then? So you watched, these are the videos that we recorded, and then this was the extra that I never got to. So I asked you to watch it on your own. You watched all these 4 videos before you covered, you went into the notes. And then these are just backup. Like, as you see, I just cheated and asked you to watch them yourself, which I think was fair, and it's fine. And you can ask me today, you know, the next day for follow-up. And but anybody who has a lot of time on their hands can watch all the old videos. I say basically the same things. I might use slightly different examples. So we're going to get into, now that we have data and we think it's good data, we are going to analyze the data. So that's what we're going to talk about here. And I have some old videos. I guess I can move them down, but I'll put our recording from today. I'll put it here and above. So with notation. So now what you see is something new here. You see all these. Now these were pre-recorded. These took me forever, and I made them like 10 years ago, but I mean, it's the same material. And they go page by page by page. I kept track of the views for some purpose. I can't remember. I think that was when I was doing my promotion application. But so you can see the time here. Now these go page by page by page, and I'd like to start doing as much as I want to get through as much as I can in the next 2 hours of this material, and then I'm going to decide if I leave some of it to you. So this will just help you, or I might just refer you to some of these videos for a deeper treatment, but well, let's see on what I end up doing, because I have to go with your needs. That's what I try and do. I just feel that's the best to keep your attention. So, and your optimal learning. So I'll move these down so you don't get confused, because these are the old videos. So you have here, again, you have the notes in English and Spanish, and you have the annotated notes. In this module, I also have a second set of notes that I've never figured out how to integrate in all these years I've been teaching. They are a set of problems that kind of stand, like I'll repeatedly turn to them, and they are the exercises that we're going to discuss. So these are like data sets. I need to close this. These are data sets that we're going to start discussing. Where do I want to start? I think I like starting here. Oh, well, I'll just talk about this. So I don't know if we have baseball fans. One year I had a baseball fan and he corrected my statistics. He was just, he just knew I had a number wrong. It's funny. So, in this example, these are small data sets. Okay, so I'm going to use these small data sets to practice or introduce you to analysis with the principle of starting with a graph to convert this data into a visual representation to look for patterns, because it's hard to look for a pattern just staring at these numbers, right? And this is not a lot of data. So you can imagine if I had a lot of data, how you're going to look at it for a pattern. You put them in a visual representation, combining numbers that are similar so that you can identify a pattern. So you're going to look for, in statistics, we look for averages, or so for our expected, expectations, we look for sort of average or expected values of what's going to come. And we look for representative measures, or we always use relative measures. So that's how we're going to organize the data so that we can look for a pattern, kind of predict what's going to happen in the future, or what we could say about what we can expect from a certain phenomenon. In this case, baseball home runs, baseball season home runs. And we have two stellar, famous baseball players, Roger Maris, who played from the 60s to the 90s, and a shorter career than Babe Ruth, that had a 15-year career in the American League, and he played in the 30s and 40s, I believe. So just looking at the numbers, because there's so few, you can actually just look at them, and I can ask you the question, who's the better baseball hitter or player? Who's a better baseball player given this data? What would you say?
Babe Ruth?
Okay, so you say Babe Ruth. Okay, why? So what's your argument? How do you defend your decision?
Because of the record. I mean, I'm not sure if maybe when we start analyzing statistics, but you can see through those 15 years, almost every year was much higher than the other.
Yeah, so excellent. So basically, when I look at this data and I think about what to expect, this guy is consistently higher than the other guy. However, we have an issue. Baseball statistics have always been recorded, and in fact, one of my PhD supervisors was a baseball fan, and he studied in economics. My PhD is in economics, and he studied baseball statistics, and it's great when you do statistics and you're an economist and you're interested in stuff. There's lots of data, right? So unfortunately, as much as that's true, and everybody can see that when you look at the career, the history, and all the entire set of data of his American League, Major League career, unfortunately, Roger Maris has more hits. And the layman will only know about this, the 61 season hits, or the year that he got 61 home run hits. Everybody knows what a home run is, I'm assuming, right? Edgar thinks for the average. Yes, you're right. So when you look at Maris, you have inconsistent, you have this high 61 year, but then you have a low of 13, or you have an 8. You have a year where he just scores, or home runs are 8. But these are in, if these are in order, I believe these are in order. What can you say? It's interesting that they both peak in the center of their career. So that's, what to be expected, right? But what's going on here is that he overcasts Ruth when Ruth is really the better baseball player. If anybody saw this data, unfortunately, usually people just see a few numbers and they don't see the whole thing unless you're a real fan. So how do we present this? How do we make our argument? That's what we're going to learn how to do in a systematic way. It's very short list of, these are very small data sets. So I don't spend too much time. It's not like, it's not the challenge is not how to manage the data here. It's how to make the argument. And we're going to do that, like I said, in a systematic way. But I'm going to do that second. I like this data set first. So this one is called the spending data. So I'm going to show you some data. It is how much 50 consecutive shoppers spent at a grocery store. And we're going to ask the question, how much do shoppers spend in the store? So we're going to, you're going to use the same systematic approach I use in the first question, but we're going to answer different questions. So how much do shoppers spend in the store? And how can the data be used to improve the store's marketing strategy? So even though we collect the data on spending in by consecutive shoppers, I ordered the data in this data set. So I have all the data here. Let me make this a little bigger. So there's two other data sets that I'll also talk about. Oh, I can't make it bigger. Oh, why can't I make it bigger? Let me see. So I put them in order, numerical order, just because it helps with the analysis that we're going to do. And you see the first person spent $2.30. Well, not the first person, but the first person in the one who spent the least spent $2.32. Then the $6.61 and so on. So I put them in order because what I want to do is I want to identify a pattern, and that means I got to put like with like, so low numbers together, and then I group higher numbers together. So that's why I put them in order. So that's your first step to getting a visual representation. So you have a lot of data to stare at here. The person who spent the most spent $69, almost $70, and so did like a few others they spent. So just looking at this data, what would it look like if we put it together? So we got to think of the right kind of visual tool to put it together. And I'm going to show you that. We're going to work on that together. And then we're going to discuss what I call the 5 features of the distribution. And that will help in verbalizing what we see in the graph. So you should always begin with a graph. From the graph, you make a summary. Set of statements, and there's 5 main things you need to address. And then out of those 5, you come up with the appropriate statistics that represent the distribution. So the statistics that I derive should be a substitute for even looking at the graph. Even though we start with the graph to guide our analysis, we end up with some numbers. And anyone who knows statistics should be able to understand those numbers, we presume, and you're going to learn some things that maybe you didn't know about statistics. Okay, so I'm going to pull up my my iPad at this point. Just give me a second. All right, so from here, so this is where the data set originates. However, we're going to go to the notes now. Okay, so if anyone wants to follow in the Spanish notes, you can open up the Spanish notes, but I'm going to work with this set of notes here. Okay, so I'm gonna start on page 2. Okay, so I'm starting on page 2. And here's the data. So I put the data out, I put the questions, and I've included a graph. So here's my graph. I want you to stare at this graph. So here's my graphical representation down here. How did I produce this graph from this data? So keeping in mind that the first step was to put them in order. I put the data in order, okay? And then I made this graph. This is called a split stem and leaf plot. And we're going to talk about it and then derive our statistics from it. So the question is, how did I produce this graph?
Are you starting in the order? So 0, 0 would be the first group, and then you only had 1, 2, and then the others were the 6.6. You put to 7, so 7, 7, 8, 9, and then you look at the next group.
Exactly. So, okay, so for people who are staring at this, I created classes. These are called classes. So I sorted the data, put it in order, and then I grouped them together to be, this group is similar. All these numbers are represented by being in this class. And what class is that? The class is so these are the different class. And sometimes when you have statistics output, they'll tell you the class. I didn't put it on here, but so there's from in a year, he could have had 0 hits, right? So I'm going to go from 0, 0 to 0, 4, and that allows for 5. That's an interval of 5. Of 5 possible outcomes. Now I say 0 to 4, but there's 5, right? Because 0, 1, 2, 3, and 4 are 5 possibilities. And then over here, I use the first digit that I call the stem. And I put it here. And the second digit I put here and I call it the leaf. So the stem holds up the leaves. Okay. And the next one, I'm going to put all the values that are between 0.5 and 0.9. The reason why I use this ordering tool is because the stem has to be the same for all the digits or all the values that fall in this stem. The reason it's called split stem is that I have divided from 0, 0 to 0.9 into 2. Another split stem could be going by 2 digits. I could go by 0, 0 to 0, 2, 0, 3 to 0, 4. That could be another way to do it, but that would be too much detail, and I don't want to do it like that. You won't see anything if you blur the pattern or you flatten the pattern so much, you won't be able to see what you need to see. And how do you determine that? Well, that's experience. That's experience and, consequences. And I'll explain that more later, why, why this is the best way to represent the data. All right, so let's look at the numbers now. So those are the classes. Now, what did I do with the numbers to fit them in there? So let me just take a sample of numbers here. All right, so the first value is $2.32, but I just put a 2 here. So I decided that the decimals doesn't matter. That's again too much detail. I simplified it by just rounding all the numbers. So 232 becomes $2. 661 becomes 7. 669 becomes 7. 804 becomes 8. 945 stays as 9. And 1026 stays as 10, and so on. So we did rounding to remove too much detail. So I'll make a note, we rounded. I want to say eliminate, but we rounded, and we believe we're going to get a good enough pattern just by rounding like that. You just round it to dollars. I have to get rid of this. Well, I don't know, maybe that's not a great idea. But okay, I'm going to move this over here.
We're talking about 00 to 04 as in years, but this spending is actually not in years, right?
I didn't say years. Did I say years?
Yeah, you mentioned something about years because I think you were thinking about the other example with the Babe Ruth and the baseball example.
I don't think I said years, but maybe I did. These are dollars.
This okay, so 00 to 04 are dollars.
It's all dollars. The data is dollars.
Yeah, I understand that, but I thought I heard you say, well, I was confused.
I could have. We have a recording. We can check later.
Okay.
It's dollars. So we're gonna go from 00 to 04 for the data, 05 to 09. And then we are in the tens. So we're gonna go till, so this one is going to be ten to 14. And again, the first digit is the stem and the second digit is the leaf. So let's see all of our numbers. Let's verify where they went. So 2 goes here, 7 goes here, 7 goes here, 8 goes here, and 9 goes here. And then we end up in the 10. So 10 will go, so the 1 goes here and the 0 goes here. So we split up the digits. So this is the tens column, this goes here. And then the values. Again, I want to use 1 again. So that's the digit, and then these, the first digit, and then these are the second digits are the leaves. All right, so if you were just going to go by 10, if you were to go by tens, you would get a different graph. And what you need to do is determine if it's the case that the 5 features are modified by your graph. You have to pick one. Now I'm picking this one, and at the end, I'm going to tell you why I picked this one rather than the other one that goes by 10. Okay. Okay, so at this point, like half the students understand this graph and half don't, and the half that doesn't say anything. So I need to know if I need to slow down about this graph. Tell me if you get it or not. Should I keep going with the values, or do you get it?
Yeah, I think it's clear so far. We probably want to, in the end, know, what we're getting out of it, right?
Yeah. So someone said it's like a histogram. Yes. And the difference between this and a histogram is, and I'll mention it again later, is that you see all the numbers here. In a histogram, you don't see all the values. You can actually see there's 21, 31 here, 38, 44. You can actually see the data here. Okay. Okay, so I am going to move this away. Okay, yeah, so this is the tens column. And there's different kinds of stem and leaf plots. Like if you ask a statistics software to do this, it'll just spit something out to you. It might have some default settings in what it's doing, and you have to rationalize, is that the way you want to do it? And you can probably change those defaults. You can produce this in Excel, but I've never done it because it's kind of a roundabout way. I'm pretty sure you can. I'm trying to think. Most of the graphs that I produce, you can produce in Excel, but I don't do that. I only do that for the linear regression, because otherwise we're spending a lot of time when we could just do this manually very easily. And the idea is just to decide what statistics I want to use. You may never show this to anybody, right? This distribution. If you think about reports that you've read, doesn't often show distribution. It'll show. So yeah, that's what this is called. This is called a distribution. I better say that. This is how the data, these are the values it takes and how frequently. So this is a class of values 0, 0 to 0, 4. So we consider those like similar, and we just put them together. And the most important thing is their frequency, how many of them there are. So in this first class, there's only 1 observation. And the second class, there's 4. And so frequency is really important. And this is known as a distribution. Like a noun. Okay, so let's look at the shape. So this is going to be beauty of the iPad. So I want to look at this as though I have a real number line. I put it on its axis, and what I do is I imagine a broader pattern. I have enough data here to say, all right, let's look at an overall pattern. So I have some options. I think that if I had more data, it would follow Oh, hold on. I'll make it a little thinner. So is this the pattern that I think if I had more data, it would look like? So when I say more data, I mean so much data that it represents the population. When I smooth like this, when I smooth the curve out like this, what I'm saying is I believe the population of data, because this is just a sample, will look like this. More data, or all of the data possible, which is infeasible, right? Because you can't analyze all the customers all the time. So we take a sample and we just assume, basically we think the pattern is going to be like this, or can't do it. Or do I think the data is going to look like that, the pattern? So which one do you like, the yellow or the blue? What are the implications of the yellow or the blue? You have to explain the yellow. You can't just say, oh, here's the data. Like, that's curious, you know, so you want to explain.
Yeah, the would be more, I mean, easier to explain. It's smooth out more, so with more data, you would expect maybe to that be the behavior you're observing.
Which one?
The blue one.
So the blue one, so you could say, oh, well, if I had more data, I think this will fill in, and most of the data is here, and there's just a few people who spend a lot. So you could say in the blue one, maybe these are local consumers, household consumers, and maybe these are restaurants or some sort of industrial consumer that's you know, buying large quantities of stuff or spending money on specialty goods. Maybe they're just going to the wine section and buying wine for their restaurant. I said it's a grocery store, so it could be, that could be the case. So you'd have to investigate to find out who these people are. But what about this group? So are you really gonna hand wave away this group? So in the end, what I decide is going with the yellow, and I do that. I say there's 3 peaks. I do say that, and I explain the 3 peaks as possibly these are different types of different types of households. Maybe they are driven by their income. Maybe this is lower income household, this is a higher income household, and this is the highest income households. Or it could be by family size. That could be another division of family size. So these are different types of households that I'm curious about, and I'm really curious about this one. Maybe it has to do with income or size of household size of household. So I don't know for sure because I don't have a data on households, but I see a pattern worth investigating later. In terms of marketing strategy, most of the people are spending a little money, like less than $25, right? Most of that data is here, like a good chunk. And then the rest, well, it'll be interesting to know what these people are buying, spending in the 60s. So as far as these people spending, you know, 20, so this group here is spending over like 70 times, let's say 60 times 4, that's $250 over here. And then to get to $250, like, you know, this whole group is probably spending up to here is spending about $200. So that's very interesting. You have to decide then what kind of customer base you want to appeal to. If you want to buy more products for the customer spending a large amount of money, are they buying a few specialty products, or are they buying groceries for a large family, or they're retail consumers and they're using your products for their services? So anyway, so those are the things you got to think about. This will be better analyze, I maybe, I believe in 3 groups, so I'm gonna stick with the 3 groups. Okay, so yeah, the blue, so what's, the blue would be the standard deviation you're saying? Okay, well, I think that's what you're saying. Well, we're gonna talk about that later. But I'm gonna, from now on, I'm gonna just stick with the yellow. I'm gonna erase the blue. And we are gonna say now about the shape. So shape is the first. So we're gonna focus on the 5 features of the distribution. Where the first feature is the shape. In terms of shape, there are 2 general statements. Or 2 general options, or I guess there's 3, but this shape is symmetric. Symmetry implies that most of the observations are centered around a particular value. Some of them are higher. Sorry, I have to mute. Some of them are higher, but just as many are lower on the other side. A few of them are much higher, but just as many are much lower on the other side. So this balances out the expectations around a center value. It mirrors through the center. Okay. So is this distribution I've drawn with the yellow here, is that symmetric? No, it's not symmetric, right? Let me just say a point about the yellow here. I call this the idealized distribution. I write like that. The idealized distribution. So idealized in the sense, if I had all the data or sufficient representative data, I believe it would look like this. And I draw this curve. Okay, so it is not that picture, right? This is actually what we call a skewed data. So skewed data can be of 2 types. So let me show you here. Let's talk a little bit about symmetric distribution. So I'm just looking at the notes now. So symmetric distributions, you will see symmetric or symmetry in a large population looking at heights and weights of adults. You'll see that. So there's a lot of in terms of demographics of height and weight for people will demonstrate a pretty symmetric distribution. Market returns to the stock market, looking at something like the Dow Jones Industrial Average or the S&P 500 over a long period of time actually has a normal distribution, well, approximately normal. And that's where this center, where what we call the average, we use the word mean for average, means the same thing. It turns out that the average Okay, one second. I hear a lot of noise. One moment, please. All right, so the average here happens to be also the middle observation. So if I was to put, like you saw the way I smoothed out that curve, I put all the data in order. And then I made a stem and leaf plot, and then I smoothed it out. That's what you imagine here. Under here is like a stem and leaf plot, or the histogram that we're going to talk about. That's ordered the data and combined it so that we can smooth out that distribution. So the mean or the average also is the middle value. Now those are different calculations, okay? So median is the so that's my short form. So 50% of the observations are to the left of it, and 50% of the observations are to the right. And how do I know 50%? Because the frequency makes the height of this curve, right? How many there are. So there's just as many here as on the left as there are on the right. So that's 50-50. Because under the curve is how much? Right, so 100% of observations in under the curve total, right? Under the whole curve. I don't know how to make this drawing, but it's 100%. So 50 would be to the left, 50 would be to the right. Everyone okay with that? Let me write, I'll write it better. %100% of observations under the curve. The other measure or statistic, to be clear, that coincides with the mean and the median is the mode. The mode is the most frequent class. It's defined as the most frequent observation, but we've put observations into groups where all the values in the group are considered the same. So we're going to say that this is the most frequent class to make it clearer. So the mode, the median, and the mean are all the same here on a symmetric distribution. Now, even though they're all the same and all their values should be similar, if I calculate them or identify them, it turns out that the convention is to talk about the mean. And that's why everybody knows the mean. Out of all those measures, the one that you probably know the best, and I think Patricia already calculated the average, or someone calculated the average. So your intuition, when you get data, I'm going to calculate an average, right? I'm just looking who said that. However, when data are skewed, and here are two examples, I'll start over here. This is an example of data like ours. It's right skewed. Right skewed means that most of the data is together, but a few high values exist. One example, well, the one that we just saw was an example of that. And when you look at spending, spending is related to income. So in general, income has a income. So if you look at incomes of a group, you'll see if you make a distribution, or you make a stem and leaf plot or histogram and smooth it out, it will have a right skewed distribution. That is comparable to a less skewed distribution. However, it's just the reverse, that most of the data is lumped together, but there are a few very small values, extremely small values. So an example of that could be grade school completed. Most people have, a grade 9, grade 10 education, and then you have many that have, so they all have high school and some have university, formal education. But there are a few people that don't have any education. So at age 18, this is my example, at age 18, you identify, or you do a survey about education level, there'll be a few people that have no education. Maybe they have learning disabilities, maybe they are, they just never had the access to education because they don't meet the minimum standard. Those are very few. That could be an example of how much education 18 years old, 18-year-olds have. All right, so what do we care? What do we care? Well, this breaks up the triad here of mode, median, and mean. What happens is, because of those few extreme values, no longer do we see that the modal class, or the most frequent class, at the center. We don't see it with the median and the mode, the mean and the median and the mode are not exactly the same place. They get split up. You can clearly see the mode here. That's for sure. But it's unclear where the mean and median, or what the median and median are, but there's some general rules. Because the mean, to calculate the average, you use all the values to compute it, right? It means that you're also going to include these very extreme values when the other values are mostly over here, and that results in pulling the measure of the mean away from the mode and putting it here. It turns out that the mean has to balance the distribution, and as a result, physically trying to balance this, where this area here has to be offset by this area here to be able to balance on C. Okay, so this long tail, if you think about this as a physical object, trying to balance on this point here is more likely than trying to balance here. If you tried to balance on A, it would tip over to the right. That's the right skew idea. So the mean should be pulled towards, and in between those two, is the middle observation. Because the middle observation, in fact, doesn't use the extreme value in its calculation. It just uses the values in and around it to calculate it. And so we'll talk about the calculation. So the median is a compromise. The mean is actually the area. The mean here balances the area under the curve on left and right of it. The median just looks at the observations near around it to make its calculation. So it doesn't use the extreme values in its calculation. Questions? So let's see if you got it. So what about here? Which one on the left skew is the mean?
The mean would be A.
Exactly. Good. You got it. So you guys just don't forget it, okay? So mean would be A. It's going to be affected. It needs to move to balance off this tipping point here. It needs to balance the weight on the other side. So it gets pulled towards that extreme value to do that. C is the modal class. So I keep on saying it, but I'm not writing it. So this is the modal class. And then this one is the mean, DN. All right.
So in the picture in the middle, if it's symmetric, A, B, and C should be basically the same, right?
Yeah. This was, I was just trying to show, yeah. I can't remember the source, but there was a point about A, B, and C. But the fact is they will all be A in this case. It was like I think it was a part of a test question or something. So, yeah. Okay, so you remembering the mean uses all values, and it's the physical center of gravity. It's the physical center of gravity for that distribution, and as a consequence, it needs to be higher than the mode or the median. So the median is a compromise between the two, and we use it to represent what to expect when the data are skewed. So you will hear when people talk about income, and maybe from here on out, you'll hear it more clearly. If you ever hear a report on income, you will hear that they talk about median income. They will not talk about the average income. They shouldn't, unless they have evidence that the distribution is symmetric. So this is the dividing point now. When you look at the shape, determining the shape will determine which statistics you use. So this is a very hard point. This is not just an illustration. This makes a very serious implication. Okay, there's a serious implication here, and this is an implication that very few people get. Okay, and hopefully you're going to remember it. So let's see. Let's go back here. So what shape is our distribution?
Here to the right.
Yeah, so this is right skewed. Right. And so we go to the second feature. That is the center. What is the center of this distribution? In other words, what's the expected value? If you were to bet on the next shopper and how much they're going to spend, what would you bet? If I said, pick, which class, pick a class, what would you pick?
15 to $19.
Anybody? Oh, you're, give me a class. Yeah, give me a class, not a number. So 15 to 19.
Yeah,
So
one.
you're saying here?
Yeah.
So you're picking the mode,
Yep.
but we just had a discussion about it. Okay, so you're picking the mode. What other people pick? Okay, 10, 15, and 16, 19. 10, 10 today, 15, 19, 16, 19, 16. Oh no, it's 15 to 19.
Yeah, the
Yeah,
average will be
very
a
good.
bit
Yeah.
high, but it's gonna be close anyways, right?
All right, so this is the thing, right? So we need to find, according to this discussion here, is it going to be here or here? So when data are skewed, we don't use the mean. We do not use the mode, we use the median. Now the median might fall, depending on the shape, it might fall in the modal class, but we can actually calculate the median. And why don't we do that? So you guys will know what that is. So the expected value for a right skew distribution or I'm not even going to say right skew, I'm just going to say a skewed distribution because it doesn't matter if it's right or left. You can also call it asymmetric. All right, so let's see, what is the median? The median is the middle observation. So I have the data on the sheet above. We're going to look at the data and determine which observation is in the middle. Which observation is in the middle? Patricia, you mean the 25th observation?
Yeah.
Okay, so some good suggestions, right? Okay, so because we have an even number of observations, so obs is for observations, you have two middle values. So the median will not be one of those, okay? The median, when you have an even number, the median will be the average of the two middle values. And this is what I'm telling you, the median doesn't use all the values in its calculation, it just uses the values nearby, right? So in this case, so there's a few things to look at. Now, this was easy because I just presented the data to you, but in general, to calculate the median, so N is the sample size. The sample size here is 50. So we're going to take 51 over 2 to find the middle. Now we can clearly see it, but when you have a larger sample size, it might not be exactly that clear. So 51 over 2 makes 25.5. So that is telling us, because an even number, so you average the two middle values. So you're using an average, but not of all the data, just the data around the center position. So you're going to take 25, the 25th observation. So this means the observation, not the value. So you're gonna take the 20.58 number and 20.89 number and divide by 2, and that will be your median. There's not a standardized symbol for median, but I'll use M. So what do you get? Right, so in general, in my notes, I have a rule, and the rule is keep 2 more decimal places than the numbers that you originally used to make the calculation. It's like just my short form of scientific notation. Anyway, that's just so you can get the same values of me, but as me. So sometimes, I know most of the time I stick to that rule. So I should actually put, because there's 2 decimal places here, I should keep 4, so 2 times, right? So I should keep 4. But in fact, you know, this is in dollars, so we just say $20.74. It's good. I just round it. This just means approximately, right? Or rounding. All right, so we found the median. Any questions about the median? If you have an odd number of values, the median will be actually one of the observations, the middle observation. Again, some people learn in statistics in high school or in other statistics classes to calculate the median by marking out observations consecutively until you arrive at a center value or 2 center values, and then you average them if you have to. Okay, this is just a long list. I don't need to do that. This is a fast way to get at the position of the median. All right, so let's just recap everything we've done. So we took this data, we put it in order, step 1. Then, or I gave it to you in order. Then we rounded because we said there's too much detail. There's a lot of data here. I don't need the decimals. I don't need the cents. I'm just going to look at the dollar spending. And I created classes for the data. And I decided what I see I like. I like that this might be attributable, the spending might be attributable to income because income will drive spending. There might be something else going on. Like I said, these could be retail consumers and these are household consumers. And we'd find that out if, you know, with whatever our means to find out that out with. But this is telling a more interesting story than if I just had covered up this second group here. And then I begin my analysis of the 5 features of the distribution. I start with the shape, and the shape will determine the other the measures that summarize the data. The shape and the graph and the shape are the first things you need to do to determine what statistics you should be computing. You shouldn't put this data into software and just punch or churn out statistics. It's useless. You need to look at the distribution. All right. So let's put down what we found out. We found out the median is, remind me the number, 20.74. And let's go on to the next. So the next thing, the next feature is the spread. A single value is not enough. There are so many values here, and I want to summarize the distribution. Again, the distribution is the values that the variable takes and how frequently it takes them. Okay, and that's defined on the first page of the notes. So a single value isn't enough. There's 20.74 in the end, it falls over here. Now it's very close to the mode. Like I said, it sometimes can fall in the mode, but it's just right here on the edge of the next class. So you guys were close, many of you. So the spread will give us a better idea of how likely this center value is. So we can say just some descriptives are that this is a pretty no, I don't want, okay, there's some different words for describing this. So you could say this is it's not so flat, but it's spread out. This is considerably spread out. There is, you can use the word volatility. Uncertainty. So spread captures volatility, uncertainty. There's some of the terms that describe the spread of this distribution. So there are 3 peaks in this distribution, and that is one feature that we'll discuss at the end. But it is flat and long, right? There's lots of variety here. So there's uncertainty, volatility, and variability. Those are just some terms to describe spread. So we can begin by looking at the range of the data. You can look at the range as the maximum minus the minimum value. So how spread out are the data? The maximum value. Okay, so I have to make a point that I didn't make before, but I did use my rule. The rule is when you calculate statistics, you use the original data, right? We didn't use the numbers here. This was just to draw the curve. It wasn't for other purposes. So I'm just going to make a note here, using original data always to calculate your statistics. So the maximum value was $69.49. And the minimum values was $2. How much was it? And 32 cents? Yeah, good memory. So what's the range of values? Oh, so you just did it. So 67.17. So that tells you the overall spread of the data. Like $70 in variability, right? Now we want to know more about how most of the data behaves. Are the data really flattened, or do they peak? And here, like, they peak, they kind of bunches up like this. And how do we look at that? Okay, so many of you have learned about the standard deviation as a measure of spread. And we're going to talk about this, or if we don't talk about it today, I'm going to tell you to watch some videos on it. The standard deviation looks like this, and I'll explain all that when you see that. So the sample standard deviation, to be clear, because we don't have the population, we just have the sample. So sample standard deviation is calculated like this. Because the sample standard deviation requires that you use the mean, we have an issue. What's the issue?
That the mean includes the extreme values.
Yes, yes. So this is also going to be sensitive to extreme values and not really representative of the data overall, and not a good predictor of data. In this course, after this unit, we are virtually going to focus on symmetric distributions, but it's important because in reality, we don't have symmetric distribution. So I'm teaching you how to present and analyze non-symmetric data, okay? But you need to know how to identify it. You need to know the risks or the, this is a strong word, but the consequences of assuming that it's symmetric and using the regular mean and standard deviation. In fact, most data or much of what you probably see is in practice is not symmetric. And we can talk about adjustments and things that you can do to make it symmetric so you can do a lot of statistics. But in the meantime, you know, you need to know how to analyze non-symmetric data. So saying all of that, what do we do? So we can't use this. So we have to use something else. So just like the median, the 5-number summary is not sensitive to extreme values. Five-number summary consists of 5 numbers. So the minimum and the maximum, we already have those. Q stands for quartiles. So this is gonna be in the quartiles, the first quartile, second quartile, third quartile. Let's start with this one. So a quarter is 25%, right? 2 quarters is 50% of the observation are to the left. Do we already know what that is? What is a position where 2 quarters or 50% of the observations are to the left? Does it sound
Median.
familiar? Yes, this is the median. All right, so Q2 is the median. So we already have that. So we have this, this, and this. We just have to find Q1 and Q3. So how do we find Q1? Any ideas of how to find Q1? So say we have this, and we have this. How would we find Q1? So Q2 marks where the data divide in half, right? So if I took the first half of data, so let's look at our example above. I've done that. I divided the data into 2 halves. And you can do that with any data set using the median. So the median does not appear in the data set. So this is an even, clear division. So the median then divides the data into two halves. This is the first half. And this is the second half. Okay, the median, in any case, in general, the median does not fall in either the first or second half. It's used to divide the data. It's a very important point. You're going to get the wrong answers otherwise. So now that I have the first half, how do I find Q1? Any ideas? So 25% is half of 50%. So this is 50% or the first half of the data. Can I just use the same rule that I use for all of the data? The n plus 1 over 2. So that's what I'm going to do. But now my n is going to be 25. What's n plus 1 over 2 in this case? Aha, so now because we had an odd number, we will get a clear decision on the center value. So it's a clear center. So that's Q1. And you could do the same calculation with the second half of the data using 13 and you could count, or because of the way I drew it, you can just look over here and go like this. So it's the same thing over here. So that's Q3. So I made it very easy to identify. In general, you can, in your ordered list or even from a picture of the histogram, not the histogram, the stem and leaf, you could do it. The problem here is you have to remember to go back to the original numbers to actually get the, the original spending. Can't use the graph exclusively if you have the data. The data is better. All right, so that's Q1 and that's Q2. Q3, sorry. So the minimum, okay, so I'll ask you, write down the 5-number summary. Just gonna take a 5-minute break. I'm gonna get some water. Okay, I'm back. So yeah, great. You copied it out. Let me copy your work. And I guess my break was longer than 5 minutes, sorry. Um, oh. So the minimum was 2.32. You can put it as dollars. Q1 was 14.35. Q1, Q2 was 20.74, which we calculated. And then 33.80. And finally, 69.49. Great. Okay, that's a 5-number summary. Now, what do we do with that? I'm gonna make it a little bit smaller because I tend to get larger and larger as I go. All right, so what do I do with those numbers? Do I just leave it like that? Do I say something? Okay, so the goal here is to have the 5 numbers, to have the 5 features replace the graph, okay? So I take the 5-number summary and I can say a few things about it. And it's going to lead into the 4th feature. What I say is going to lead into the 4th feature. So what I'm going to say about it is, this is a long gap, not a gap, but this is a broad range between these 2 values. And that's that tail that we see, or that extreme value, 69.49. There's a few others, right? So we want to describe that. And what we're going to do to describe it is we're going to distinguish between the regular part of the data and then the unusual or the curious extreme part of the data. And so what I'm going to do is I'm going to introduce the idea, and this is another measure of spread, is the IQR. It's called the interquartile range. The interquartile range is exactly that. It's computed within the 2 quartiles of Q3 and Q1. So this is what's called the 75th percentile. 75% of the data is to the left of it, or we call it the 3rd quartile. So percentile is just that. It says 75% of the observations are to the left. The Q1 is the 25th percentile, where 25% of the observation are to the left, or it's called the 1st quartile. And up here, I'm going to add that word for the Q1, Q2 is the 50th percentile. So percentile is the value where P% are to the left. It's always talking about the left side. So what's Q3 minus Q1? Take this figure here, this number, and subtract. So $19.45. So this is how much of the data falls in this range between the 75th and the 25th. How much data, how many observations, what percentage of observations fall between the 75th and the 25th percentile?
50%?
Right, so 50%. So about $20. The middle range of data is spread out by $20. $19.45. But overall, the range is spread out by almost 70. Okay. And from the graph, we know there are some extreme values here. Clearly, they create their own little universe over here, and they're distinct, that they're worthy of investigation. In statistics, we actually have a threshold for extreme values that we use just like a rule, right? So that we can justify investigating or doing something about them, like investigating whether they're accurate to begin with. Is it possible that these were computed wrong or entered wrong? Or are they just a different characteristic that we need to pay attention to? So the curiosity draws our attention. The first step is to determine, is it really strange to see these values? And the way that we attribute uniqueness or whether it's normal to see that or common is to say that, well, the 50% in the middle is spread out by $20. So what we're going to do is say that most of the data should be spread out similarly. Okay, so let me I gotta grab my drawing because it works very well to show you the data. This is the one. Oh my goodness, what happens? That's not what I wanted to do. All right. So what I have here is called a box plot. And it is a representation of the 5-number summary. So this is a graphical representation of the 5-number summary. And I've plotted here the minimum, the Q1, the Q2, the Q3, and the Q4. Oh, max, sorry, max. This is the max value here. And then I have some other calculations. So let's go through them. I did the IQR already. And now I want to use the IQR so this length that I'm drawing is the IQR. Oh gosh, let me just copy it. It's easier. So this length is the IQR, right? So I know there are extreme values on this side, and I want to check. I want to add one IQR this way and a half of an IQR and that will bring me to here. Oh, maybe my drawing's a little off scale, but so this is one IQR. And this whole range here is supposed to be, hold on, let me do this a little cleaner. So this is one IQR, and then I'm going to add another half of an IQR. So this total thing that I'm adding, so what am I doing? I'm on top on, oops. Oh. So this is Q3. So I'm from Q3, I'm going to add 1.5 IQRs. And that's basically this calculation. And I'm going to get 62.97. This threshold, beyond this threshold, I will say are values that I consider in statistics outliers, statistical outliers. Okay, they're outside Q3 plus 1.5 times IQR. Or on the other side, Q1 minus 1.5 times IQR. I'm not checking on the other side because there's no extreme values. This is within the range of the IQR. So I'm basically looking that this is the guiding range. And anything beyond that, beyond 1.5 of it, I'm going to consider them strange enough worthy of investigation and research to determine first if they're valid, second, what they mean, what they imply. So there are actually 3 values, not all of the values that are above, that are higher, are considered outliers. So let's go back to the data and see. So this is the number that I'm going to compare them to, 62. I go back to the data and I look and where my number went. Oh, there it was. Not gonna work. So 62,975. So any values higher than that. So you see this one falls out, 6157 doesn't fit. So only these 3 are considered statistical outliers. Even though the other one is extreme, it doesn't fall into that category. Questions? What, you have a question?
Sorry, I do have one. When we are calculating the IQR, do we always use the 1.5?
Yes.
Does that number remains the same?
Yeah, the 1.5 is the rule we're gonna use.
Okay.
Yes, so what you're getting there is the threshold here. Yeah. So you always use the 1.5. So what you're saying is, I think this is a regular, so I'm gonna give it a little bit of, buffer. I'm gonna give a little extra, and the little extra is half. So this is 1.5 up to here. Like, I didn't make it perfect, but I hope you get the idea. I'm going all this range. All this way. That's 1.5 in my drawing. So, so these values are all statistical outliers. I'm trying to avoid my writing getting too big. Okay, so then that gives us the results for the next part. I just want to say one more thing about this and what we do with the 5-number summary. So we can make a box plot. We can identify strange values, what we call statistical outliers, as the values outside of Q3 plus 1.5 times IQR. It's only on the right side. So I identify, go back to my list of data, and I find these as extreme values. I'm sorry, outlier values, statistical outliers. Now, I can also do something else with the 5-number summary and the box plot. I can, without the graph, I have a graphical representation of the data. Now, the numbers are not here. I just have some key points that divide the data. And what I can see is the shape. From the box plot, I can see the shape. And the question becomes, are we going to call it symmetric or skewed? We know this is skewed. We see this tail. It's very extreme. But sometimes, depending on the relative spread of what's inside the box and outside, we call this the whiskers, like on a cat, the whiskers. So these outside of the box, the interquartile range of the box, are called the whiskers. And the whiskers should be analyzed together, and the inside should be analyzed together. So what am I going to look at? Okay, let me go back and take this drawing again. I'm going to do that because I want a clean drawing. I'm going to take it back. I have to use this because there's no way I'm going to draw it to scale like this one is. So I have all these numbers. I'm going to erase these numbers. It's not the point of my discussion right now. So without these numbers, what I look at is I compare this and this. Now, is that symmetric within the box? It's not in the middle, right? So we say that in the box, it's right skewed. Then we look at the whiskers outside and I compare this one. Well, I'll use a different color in case you look at this later. So I compare this distance with this distance. Are they even? No. So outside in the whiskers, it's also right skewed. So because these reinforce each other, we say the shape, which we already knew, but this is just another way to look at just a box plot of the data. So the shape is right skewed. Now I have a video where I draw a bunch of different box plots that not necessarily the case. So for instance, I could have this. Let me make it a little bit smaller. Okay, now this, using the same logic, let's do it. So comparing this to this is right skewed inside. But then comparing the whiskers. Oh, I did it the wrong way. What am I did the wrong way. Do that again. I didn't want to do that. I'm trying to make my point and I forgot my point. Now going to the whiskers, it looks like it's less skewed. And it turns out that this left skew and the right skew are about the same. And this distance is about the same. And so overall, if you actually graph this, the overall shape will be symmetric. Okay, so in general, when you look at a box plot to determine the shape, you need to do this analysis. And I have a whole video in the recorded videos that demonstrates that I'm going to recommend you watch. I recommend you watch all the pre-recorded videos, not the lectures in class. Well, maybe, yeah, that too. I'm gonna refer all the videos to, but I mean the pre-recorded edited ones in the long list that are like 1 or 2 minutes long. And they're all named. It's all explained page by page in the notes. So so the overall shape is symmetric. Any questions about that? You get some practice because I do some drawings just as bad as this one to make the point. Okay, so you can do 2 things with box plots. You can identify outliers and you can determine the shape. We already have the shape, so we didn't need to do the shape thing, but I wanted to mention that to you because that's also an important topic for this course. All right, so we arrive at the 4th feature of the distribution, and the 4th feature is called gaps and outliers. To determine gaps and outliers, you look at the distribution for the gaps and you see if there's any gaps in terms of, are there any classes with nothing there? So you go back to the so what do you see in the drawing here? So between 54, and I write it like this, to 59, you have a gap. You have no data. Now you have to still draw it because what you have under here is like a continuous number line. So you need to show that there's no data. It's very important because look, it separates the second peak from the third peak. So that's really interesting. So we mentioned the gap. It also reinforces the fact that these are outliers set apart from the rest of the data, right? Data set apart from the rest of the data. In fact, there's a gap to set them apart. So that's important. And then we're going to mention the outliers, and that's all we're going to do there. So gap is 54 to 59. And then you can mention the statistical outliers. I have to get that list again, the one here. Always going back to the original data. Okay, and that's it. That's all you have to do. We did all the work already. I spelled outliers wrong. Outliers. And the final feature are the peaks. There are actually 3 peaks. We call this a trimodal distribution because there are 3 modes. And we're going to use the modes of the peaks to identify the peaks. So where are the peaks in terms of the mode? Go back to the drawing and see. So we have one here, and here, and one here. So the first one is from 15 to 19. The next one is from 30 to 34. And the last one is from 60 to 64. Comments, questions? So I use the mode to identify the peaks. Oh, did I read it wrong? 55 to 59. Yeah, sorry. Yes, you're right, Maite. Thank you. So the gap is 55 to 59. You're right. Let me correct. And I'll correct it when I get down there. And did I take these? I did take these, and I'm going to do it again. Did I make any other mistakes? Copy. And the gaps was 55 to 59. And that's it. Okay, so we have all the data there. And we have all the five features of the distribution laid out. These could go into our report. These 5 features could comfortably replace the overall graph that we did, the whole graph. And anybody reading these 5 features should be able to visualize the distribution in all the in any significant way. And be able to draw conclusions. So what's the conclusion? So what we're going to do, okay, do you guys want to anything from this? I guess, I mean, I can upload this page so you have a record in Moodle. It's hard to put it on, you can't have it on one, it's like 2 pages worth. But I'll put it up on Moodle as 1 page. Any questions about anything? So 5 features: shape, center, spread, gaps and outliers, and peaks. And so what we do with this is make a conclusion. Now the conclusions are all, hold on. They're all written up in the sample problems. I have to find out. So, oh, I think, okay, so I'm going to go back to sharing my screen. All right, so this is the data. Remember back here, we got the spending data. And what I have is the data presented, and then I have a discussion of making the graphs, and I have a summary. So let me go to the summaries. So here's a summary. That's for the first data set. You guys can read through that. So this is for the spending data. So this is in what the document is called sample problems. And I have a description of what we just did, the shape, the center, the spread, the gaps and outliers, all the calculations, and then a discussion of peaks. And finally, and I put the dollars in just to be more precise. And then I have my conclusion. The center of the distribution is at the median of $21. I just rounded to dollars. But 10% of the customers spent over $50 each. The shape revealed by the stem plot, therefore, is of interest to the store manager. If the big spenders can be studied in more detail, steps to attract them may be profitable. So that's my conclusion, my discussion. You could have more. You could say things different. Whatever you say in your conclusion must be reinforced by all of your 5 features. Okay, don't have 5 features and then say something speculative. You know, refer to your results. And just some additional point that I make, if I am to display the data as a basic stem and leaf going in intervals of 10 at a time, this is the graph you get. And as I explained, you lose the second peak. So this, as much as we discussed eliminating too much detail when we made the stem and leaf graph, we did allow detail in terms of splitting the stems into 5 intervals of 5 because we didn't want this. This is just covering information. This is covering the second peak by putting it all together. So I justify keeping it like this because we see a different graph. Because we see a different graph, we have to make an executive decision which one we're going to pick. And we like the idea that we can say something possibly of middle income households or middle spenders, whichever one it is that we can investigate. Okay, so any comments, questions about that? No, so you learned a lot. You knew some of this stuff. I hope this was revelatory. So what you're going to do this week is go through. I'm going to recommend you watch some of the old video because I think I do this analysis with Maris and Ruth there. We already had, let's just talk it over. Let's talk it over because now you have an idea of how to calculate things and it's just a matter of reviewing. We agreed, I think, that Ruth is the better baseball player, but we have to make a good argument. We're going to use the 5 features to do that and refute this 61 figure as simply an outlier, a statistical outlier that's very strange and unusual and worthy of investigation, including well, at the time, they should have investigated if he was using sport, performance enhancing treatments, steroids, whatever it is. And I don't know if they did, but possibly they did, because this is a very strange figure. Okay, so as I said, when you see and you have evidence of an outlier, you should pursue investigation. In statistical terms, though, I think I find out that it isn't statistical outlier, but it's right at the border of it. So it's still worthy of investigation. And I don't mean like criminal as much as I'm just saying, statistical analysis type of investigation. All right. So let's look at my drawings. So here are my drawings for, Maris and Ruth. And just looking at them, what can you say about Maris and Ruth? Now, I have the drawings vertical, but you would do the same thing, putting them on the horizontal. What is the shape of Maris data? What is the shape of Ruth's data?
Both are skewed.
So right now you think that Maris's data is what kind of skew?
Mhm.
Maris is right skew? And look at the gap you have here to argue that it is skewed. Clearly it's skewed, right? So that gap is confirming that. And what about Ruth? What about Ruth?
Less skewed.
So I don't think that's really a skew. And the way you could check that is by making a regular stem and leaf plot, which I do. It's not really left skewed. So a skew needs a gap and a space. And the problem with this drawing for Ruth is that I did it by split and it spread out the data to make it look really flat. But if you just go by tens, which you have enough data to do, you'll see that this is symmetric. So what I ask you to do here is to make a back-to-back stem, split stem and leaf. No, I think you should just do a regular stem and leaf plot. So let's do that before we go, and then we're going to go so you can see what that is. And then I'm going to leave you with all this material to work this week on just this general topic of statistical analysis and basic 5 features of the distribution. You are going to need to learn all about how to analyze a symmetric distribution, because I taught you about a skewed one. Okay, so that's going to be explained in the videos. I will put up a Connect assignment on this material and have it due during the week, like after the class, so you can ask me your questions during the class, right? Next week. So yeah, I'm going to have a Connect assignment for this. All right, so let's do this before we go. The back-to-back stem and leaf plot of Maris and Ruth's data. And then I'm just going to encourage you to read through the rest and watch the videos to do that. Let's see how much you can get through this week, and we'll catch up next week with where you're at. Yeah, you should be able to see. Okay, thank you, Maite. You should be able to see the results of the Connect assignment now that it's past the deadline. What just happened? Oh yeah, there you go. All right, so let me grab this data here. All right, so we're going to make a back-to-back split stem and leaf. Oh no, we're just going to make a back-to-back stem and leaf. So I'm going to use 0, 1, 2, 3, 4, 5, 6, and I stop, right? Because I'm going to do that because it goes between 8 and 61. And I'm going to plot Maris on this side and Ruth on this side. And for Maris, okay, the data is not in order. So you have to do that extra step of putting the data in order. So once you put them in order, I'm going to just do this the fast way. I'm going to just read off of here. So it turns out, because I only have a little time here, Maris is going to have 8, 3, 4, 6, and you guys can confirm this. And then 3, 6, 8. So step 1 is to rank, right? Step 1, order. Observations. 3, 6, 8, and then 3, 9. And then 61. And Ruth, and so this is the stem. And this is the leaf for Maris. And this is the leaf for Ruth. And then for Ruth, it's going to go 22, 25. And I go from right to left. I do things backwards. And then 30, 34, and 35. And you put them one under the other, even though they're different numbers, that we're treating them like they're the same, and we're counting the frequency, how many of them there are. And then 41, and 41, and then 46, 46, 46, 47, and 49, and 54, and 54, and 59, and 60. And now you get to see what you want to see is a symmetry. Whereas for Maris, you see that gap. All right. So I'm going to leave you guys here. I'm going to make some notes about which videos to watch to get through, and just do as much as you can. If you can't finish this week, then we'll have the weekend to discuss and you can work on the weekend. That's my objective. But hopefully this is a good start for your review. Any questions for me? No, you're not going to have time for module 4, I don't think. But if you do, if you're already ahead, go ahead, keep going. So I'm going to focus on module 3 this week with assignment and connect. But go work on ahead. I'm happy that I can offer you that you know, that material that people who have the time, they can work ahead. That's great. And then really when we meet, you're just getting a review. Yeah, because I think next week we'll probably just do some review of module 2. This is a big one. And then I can begin the introduction of 3. After I hit the main points, I got to get through some main points that I wasn't able. The main thing for this week that you're going to start is looking at how you analyze symmetric distributions, learning about the standard deviation, and watching my support video. So just before we go, well, I guess it's 12 o'clock. You guys could go. But I just want to show you those videos again that I keep talking about. I'm talking about these videos here. These ones here that are page by page by page. So you pretty much have every page of the notes explained. So you're not alone. I'm right beside you, showing you how to solve the problems. I didn't have a chance to do the calculator calculations, but I do them in these videos here. So I think I'm going to start you with these conference videos and then send you to do the review, because in these older videos, the edited ones down here on YouTube, these are using another calculator, a single variable calculator. Does this one that we use now, the TIVA 2+, is more powerful, and I demonstrate how to use it, and we can talk about it some more next week as well. Okay, so have a good week. Keep in touch. Keep me posted on your progress, and I will post this video and some instructions. Okay, bye.
Professor,
You.
excuse me.
Bye.
We have a question because we cannot see the grade per se from the quiz on Connect. But if we do enter on the study mode and, go ahead and redo the quiz, it will tell you what you got right or wrong. But we can't see the results that will be accounted for in the class for the grades and everything.
Okay, so I'll look at that. I don't know. Connect has some different features. I have to check. I don't know if I can change that feature either, but if I report your results on Moodle, that'll be satisfactory, right?
Oh, yeah,
Professor.
because we'll know.
Yeah, exactly. Okay, so I'll do that.
Professor, is that they're not through the assignment. There's a menu tab on Connect that says results, and there is that you can see your grade and go through what you got wrong on the actual quiz.
I don't think everybody has access to it because I just went through results and it says that the instructor has not
It doesn't.
released it.
Yeah, you can't, it says instructor is not displaying scores right now. So I'm guessing people are just like randomly assigned to what they can see or not see and Connect, I don't know.
I'll check the settings. I'll check the settings. Let me see. I'll stop the share. Well, I mean, I don't care if you guys see what I'm doing.
Yeah, Professor, but I think it'll still be good even if you can improve, the settings in Connect to still include in Moodle as well. I think it would be good to have it in both tools.
Yes. No. Let me see. Oh, I don't know. It's not letting me in. Anyway, I'll look at it. I have a few minutes before my next class. No,
Thank you.
why? Sure.
Thank you, Professor.
Okay, have a good week.
You too.
Thanks.
Thanks. Have a good weekend, everyone.
And bye.
Bye.
So Professor,
Yeah.
excuse me. So we during this week we continue with the assignment on Connect with module 3. So the next week will be module 4 before the exam.
Yeah.
Okay.
Professor, I thought you said that the assignment for Connect will be for next week, right? For module 3, or wasn't that?
What's that?
I thought that you said that the assignment for module 3 will be due next week, wasn't it?
Module 3 will be due this week.
This week or next week?
I don't know the difference. Saturday, you should have module 3 complete.
No, I mean the assignment that you're gonna put in Connect, which is the question he just asked.
No, if you asked about the test, yes, it's due for next week, but like after the class.
Right, and it's gonna be module 3, not module 4, right?
Right.
Okay, because he said something about module 4 next week. And then will the exam include module 4 or only up to module 3?
We'll see what I'm gonna do. I don't know. We
Okay.
have to see the progress.
Okay, perfect. No, I appreciate it. I was confused with when he mentioned module 4 before the exam and also the assignment being due this week. That's what confused me. I thought the assignment was due next week. And then you'll figure out about module 4 also within, the next class.
Yeah, we're gonna see, because obviously we are delayed, but we'll figure it out.
Okay, thank you very much. Have a
Bye.
good weekend.
You too.
Thank you.